Hey, welcome everyone. This is another video where I will be taking the class of the third milestone, which is based on dimensional reductions, feature extraction, and returning the same models with namespace, uh, nearest neighbors, and support vector machines. I hope you will like this video. In this video, I will be talking about these concepts of dimensional reductions, how do we do that, and else, and the feature extraction parts and all. So basically, in dimensional reduction, the word is very imminent. We are reducing the dimension. If anyone asks me what is the dimension in physics, I will tell that x, y, z axis, that the length breadth, something like this for the axis and all. 2D is basically two dimensional, is the xy plane, and three dimensional is x, like length, breadth, and height. We can easily say that. But the things also comes over here, the same thing, but in a different way. If I tell something about dimensional reduction, it basically means we are reducing the features. Reducing dimension is basically another word for reducing the number of features, and that's it. So this process is much evident, and obviously we require this for our own purpose in machine learning algorithms while preprocessing the data. Like it happens in some cases, for example, many models don't accept huge features, so we cut the features off and try to take unique features or try to get good features from the selected amount of features which is provided to us. Here, the same thing is there. Suppose we are using this dimensional reduction technique over here. So why we are using? Just I am just telling you. I'm giving this example. So basically here we are actually uh, like defining that we may need something that is which is relevant to us. For example, we want the things to be more convenient. For example, if there are 10 features, all features may not be equivalently required for us to do. So for that, we do the dimensional reduction, which is a part of feature section, whatever you say. Both are same or both are different. It's up to you, whatever you think. But more or less, the things are same. Dimensional reduction is a technique where I am basically decreasing the number of features, in a way, selecting the best features, and feature extraction tells the same thing only, taking the best possible features available over there. Next comes the like I have given this a good preview over here. So it reduces the complexity. Obviously, some models like PCA, like SVM and all, they require very small amount of features. So here the dimensional reductions are required. The probabilistic models require the dimensional reductions. Yeah. One more thing, the risk of overfitting is reduced. Why is this reduced? Because there may be some data where the data is too sparse or too much maybe there, so there we can reduce the whole system, or we do not require that sparse data, and we will shift to the normal data. Sparse means where maximum columns are of same type of data. That is sparsity. Means filling with same number of entities and all. So we can reduce this. Obviously, improves the performance and all. You can obviously read this whole thing. I am just pausing it according to your choice. So common techniques are PCA, T-sign. T-sign, I think you guys not know or not, I do not know. But feature selection is there. Autoencoders is obviously used in neural networks, which you will study in other parts, not in this MLP projects and all. Another thing, what is dimensional reduction? If I show you a picture, for example, okay, do not see this as an information table. See this as a normal table or normal information. For example, algorithm best for like all the data set you can read, nothing problem in that. For example, here, this algorithm best for complexity scalability, there are, I can say this, there are five rows and five columns. If I'm not wrong, five rows and five columns. So we can say that five features are over there. So basically, how the dimensional reductions work. For example, I use the PCA. PCA is the best thing, which is obviously required. You will learn the PCA only. So if I use the technique of PCA, so what does PCA tells us? PCA actually tells us that we are using this. The features are algorithm based for complexity, scalability, and interpretability. Interpretability. So these are the five features, and of these five features, I want two important components. Like we have the n components, we need the components of a PCA. So we need only two components to be the best. Like we are actually telling the model or telling the model to get the best two possible features out of this five features. So what it does, I'm just showing you. See, this is the two things. I have used different types of names just to make you understand. But why these two names? This is not actually the similar that of, like, you cannot take algorithm and complexity for these two types of things. It is actually, in short, if I tell you, it's a projection. Uh, or if it is a projection of all the features. For example, algorithm best for complexity, scalability, interpretability. All the features shadow or projection is used in this below technical use case. So this is the best example if I show you how dimensional reductions works. Because in the upper one there are 5 features. Below there are 2 features. Yes, obviously the 2 features is obviously easy for the computer or the machine to understand more easily. Having a good like reducing the overall computational cost and all, that is the features and all. So this is what dimensional reductions are known for. Next, we are coming for feature extraction, which is just basically the same thing. If you know this technique of using the PCA, we use the same technique of features extraction, because after all, PCA will give us two, like this. I have here used 2 features, so it is giving me only 2 features. Next, we comes the both things that I have told you, like basically meaningful terms only. Next, we comes as retraining the model is also there in the third milestone, but that is very easy. Classification algorithm. What is the classification algorithm? So where we need the classification type problems, where we want to label things and all. So in this type, we will be doing this naive base. I think everyone knows it's use the base model and all. TM nearest numbers, like it's use the grouping type of data. If you search the internet, you will get like many examples on this. SVM is basically a vector machine where, like for example, you are imagine a XY plane, and in the first quadrant there are some data which you can separate by a single line or a linear line. So it's like a vector machine in a linear dimension or non-linear dimension. If you use the kernels and all, that's it, nothing else. So this was the text content for the preview content for the PCA parts and all. And now we will see how the practicality works and all. So basically, I was doing this only. So dimensional reduction, see, again the same thing. If I also do not know what I will do, I will read the documentation. For from SQL under decomposition, I am just importing the PCA, and from the PCA, I'm seeing it. Okay, see here, I read the n components. Why this is required? This is the main part where we require, like we are telling the model, I need out of the 10 features, I need the 2 most powerful features. For example, I'm showing you this thing. I have done this with a random one, but what I do, I just increase the number of features. For example, I give 4, 5, 6. Here I am giving 6, 7. I think 3, 5. 5 are there. Okay. Let me calculate it. I'm just doing. Okay. 7, 9. Okay, 5 are there. There. Okay. So what I told him, that give me 2 important features out of the 5 important features. Okay, let me show you this one before. If you don't understand, let me show you. I'm printing the X one. This is X basically. So it is actually this one. 5 features are over here. I think no issues with that. So I will now just tell it, and basically the same structure. If you see the documentation of, you will get, we'll be using this fit function. See PCA in components 2, I'm using this fit option, dim reduction dot fit X. So it's given this, and with the attribute property, I think everyone now understand how to see the documentation. If you go to this attribute section, where is the attribute section? Let me find it. Yeah, this is attributes. So this component gives us the features. So I will just click on this. Can you see this one? It gives you the features and all. So yeah, obviously, out of these 5 features, that is okay. Let me print it also. Out of these 5 features, 1, 2, 3, 4, not 5, sorry, 4. It is giving me 2 features. But remember one thing, the size would be same because I am taking the projections, because these things, this 1, 3, 4, 5, 6, like if you go to the mathematics, you will understand it very well from the theory part, but I will not tell that theory part because it is not required. I think that basics you must know. That is the main thing. So what it does, I'm just giving an example. X is there. So suppose think like this one, this suppose this is a row 1, 3, 4, 5, 6. So it is doing the linear combinations of this, like 1 into 3, or like how I will say this. Suppose it is taking the linear projections. For example, the initial formula is taking the mean, subtracting from the means, and all that is things. And by giving a general idea, it is taking part-wise things. For example, in the first row, from this first row, it is taking like 1 plus into 1 into 3 plus 4 into 5, something like this. Then again taking the second part is like this, but usually it is taking the two components. Basically, what I mean to say, it is taking a shadow of all the features, because it is taking, see, 1, 2, 3, 4, 5. Five are there, but two, only two features are there. That is of sure, like that is no doubt of that. But instead of four features, it is taking actually two features because we have told it. But the other thing is that how it does, it is actually taking the projection of every features. Remember this, it is taking the projection of every features, nothing like that's it. And this is also a part of the feature selection also. And by this way, you can do the feature selection. Okay, let me show you by giving some good examples. Suppose I'm increasing the length, then you will better understand. I think 5 or 3, 3, 6 or 1. Then increasing the length, just see the difference. 4, 6, 7, 8, 1. Now I will show you. See the number of features over here. Okay, if I give you the shape, then you will understand. 6, 5. But where the components will be, see, again 2 only. Why 2? Because we are providing 5 entries. Sorry, 6 entries. But we require only 2 important features. That the whole purpose, like how the feature selection is being done over here. So this is both same. Dimensional reductions and feature selection are what you will say, brothers of same area, you can say. So basically both terms are useful. So I think you can know this by seeing the documentation, which is even very eminent and all. But if you want, there is a best way to see that. And this is how the whole things occurs over here. This dimensionality and all. We will first check the features what are there, and then use the components part, and then basically you would use the dimensional fit function to get our desired things. And all the internal calculation which is there, please read the theory very well. That is required as much as you read the theory. That is the most important thing. But I have discussed the maximum majority part, which is required for the live and all. So this is how you do the dimensional reductions and feature extraction. Another thing comes is model retraining. Okay. So I think by the term they are meaning that we need to retrain again with the model. For example, we are using this thing, this x. Suppose we are taking this x equals to this one. Suppose equals to this, and if I give this one x, not x, I will use another query. This is not okay. My bad. But you need to change it to the data frame, because if I give y dot whatever y dot info, it will show me here, I think. Yeah. Or it's a capital one, my mistake. NumPy doesn't have. Remember this one. What you need to do, just change it to a data frame. Okay. For changing to data frame, what I will do, y is equals to y dot to data frame. I think this one is p dot, okay, pd dot to data frame, pd dot to data frame. I think this one is okay. Okay, let me check the pandas first. I have also done a mistake, don't worry. But how to do that, I am chilling. So I'm going to say this one, and I will check what is the data frame. Okay, to data frame. Okay, let me get this. Yeah, okay. Only data frame is there. Don't. Okay, I have done this wrong. So I will just copy and paste it over here. Okay. Now let me check the y. So now what I will do, I will use this data, this x comma y. Let's do a good thing, x comma y, and what I will do. Okay. After using this xy, let me use another thing, but otherwise x1 y1. I will be getting confused. That's it. So I'm using this xy, and what I will do, I will just use this. Okay, I need to import the things also. I don't. If you guys remember from sklearn dot model selection, I'm importing trend test. Yep. I think everyone remembers this, right? It's a very like it's a very normal, but I'm showing you the example. Trend test. Yep. Okay. Okay. What I will use, or not like this. Okay, I'm doing some error or what? Okay, not like this. Okay, my mistake again. Sorry. Okay, so if I give y of 0, 0 to 3, and this one else like y of 3 colon 3 colon, what it should be. Okay, y is not defined. Where is y? Okay, it's be got to remind. Okay. Let me check the x1 first. Okay, it's good. The y1. Okay, I think it's error because of this that one. Let me check the x1 again. Okay, I'm taking everything, but it should not be like that. It should be like colon, okay, it should be comma, I think. Comma, then um 0 to 3. Okay, I'm going to check the panda direction, just a bit. Okay. I think it's working or not. It is telling okay. If there is some error or what? See the slicing or not. Okay. Okay, just I'm giving this example, then you'll understand. And like I don't have data frame. The problem is that I want this two and pandas. I think there's some problem with the pandas, but let's do. Suppose x1, we're having this y1. Okay. And well, let's do one thing. I will take this whole y, like whole y, and I will just use a new data frame that is pg dot to its data frame data frame. I will use new and w. And what is new? I am just defining. New is basically entry dot array. I'm giving this to two levels, that is 1 comma 2. No, I need two things. That is 1 and another is basically 3. Let me check the y. Give me w. Yeah, it's getting good. We need these two things. Okay, done. Let me check the y one. Yeah. I have done this thing. I have created these two things. So what I will do, I will just now once the data is done, I think you know how to do the trend like the trend test split. So I will just use this x trend, y trend, sorry, x test, y trend, y test. I will use trend test split and then give this x1 comma y1. Then I will give nothing. Okay, okay, I've not done this one. Sorry, my bad. So you have done this, and then we will do then we will import the model from sklearn dot for example tree trees for neighbors. Sorry, not for the trees, for neighbor. I think for neighbors is for NHGP or so. Well, let me check the sklearn. I do not also know, but I will check from the documentations. What I will search the directory and see over here. I will get neighbors, neighbors, neighbors. So how to import this from sklearn dot neighbors. Okay, okay. From this sklearn dot. Next we have basically there is a I need actually okay SVM also is required, so I will use this SVM and neighbors are required. This is a neighbors. I will use basically copy this and I will use this from sklearn dot. Okay, still having confusion what to like import or not. What will be understanding? Just use this. For neighbors, I have used this. It gives me a list of things. Basically, we need this classifier because we are actually dealing with classification problem. Copy this thing and I use this import this one. I'm just showing you the technique how to code. So for the neighbors, for example, if you want the second part, like you do not know what is there in the SVM. I know SVC is there near SVC. What do you want to use? You can use. So SVC is there. Go and import this one. Next, you do not know about this near base also. Just copy this. Let go and paste. Let me see what is there. For example, here is the Gaussian in your base. Whatever you use. Like for example, if there are multiples, then you should use the Gaussians and all. For example, I'm copying this and I am just pasting this, giving a run through. Then I am using this model equals to Gaussian. Not Gaussian and going for SVC, a normal one, SVC. Then okay. For example, then you are giving this model dot fit x1 trend, y trend, and all the remaining entries and all. This is how actually you code. Extreme is not defined. I have not defined this one. Oh, okay, not x1, it is extreme. Okay, what is the reason? The number of players to be greater than 1 got 1 plus. Okay, I'm just telling you the way. Let's see which how you will do because it is a classification problem. I am giving here the regression things because I am showing you the basically the examples, but how the data set would be there, you should do that according to you. I'm just giving you the example. So here again you will call the models and do the following trainings. Since I have created this data frame, so it's giving me some random answers. But don't worry, when you will get the data sets, for example, the data sets, then you will work well. That's it. So yeah, that's all for today's class where we have discussed the coding part and the theory part. I hope you enjoyed the class. That's it. Thank you for watching.